Hi, Year 12s. So, on to subtopic 1.2, photochemical smog. Now, one of the main pollutants that we're going to be focusing on here are nitrogen oxides. So, they are molecules with nitrogen and oxygen in them. Now, what you'll see, start with our laser pointer. So, I've labeled each of these equations here. So, the first one we have number 1, the second one is number 2, and the third one is actually a combination of 1 and 2 together. Now, the important thing here is these reactions are involving nitrogen and oxygen, which are both found in air in decent quantities. These reactions don't just happen, by themselves spontaneously, because nitrogen is a very stable molecule. It has, as you can see in the top right here, you've got nitrogen attached to itself in a triple bond, which makes it hard to break. Because it's so stable, it requires very high temperatures to break it apart. Now, as such, these reactions are generally only going to happen in extreme situations. For example, inside the engines of combustion engines. Inside bushfires, there's furnaces inside in factories that have very high temperatures, as well as something like lightning, where you get localized very high temperatures passing through the air where the nitrogen and oxygen are. Now, equation 1, you can see we have our nitrogen, which makes up a lot of our air, our oxygen, which also makes up a lot of our air, combining together in a reaction to make nitrogen oxide, or nitrogen monoxide. Now, this substance, all of them are gases. This substance is considered a primary pollutant. A primary pollutant is the first pollutant that gets made when you combine two other substances together. So if you have nitrogen and oxygen combined, you make this chemical here. That is a pollutant. That's the first pollutant that happens directly from those reactions. That's considered a primary pollutant. Now, if you take that pollutant, so that NO, and you combine it with oxygen that is in the air again, in these particular ratios, so 2 of these with 1 of these, you can make nitrogen dioxide, this substance here. Now, if you would like, you can actually combine these 2 reactions together in one big step. So you start with our nitrogen, and instead of combining it with just 1 oxygen as per equation 1, you combine it with 2 oxygens. You can skip straight through to the 2NO2. Now, the importance of these reactions is that if we have lots of our nitrogen oxide in the air that you're breathing, you can absorb it into your body. It can actually stop the hemoglobin from effectively carrying oxygen. Now, we have hemoglobin in our blood. Its purpose is to carry oxygen take the oxygen that we breathe and carry it around our body. And if it's inhibited from doing that, we're going to generally have a bad time. Now, a second contribution is acid rain, which isn't as big of an issue as it has been in the past. But when these nitrogen oxides are in the air, formed from these polluting activities, it can combine or dissolve in the water in rain, which is also in the air, and it can make nitric acid, so HNO3. Now, when that falls onto particular substances like sandstone, it can dissolve those things away. Now, we may not have much of that sort of stuff in Australia, but a lot of places around the world have structures made out of these materials which then get dissolved by this acid rain. Now, if we go to the next section, this one is talking again about nitrogen oxides as well as ozone as being pollutants in the troposphere that are associated with photochemical smog. Now, troposphere is the part of the atmosphere that is closest to the surface, so the one that we exist in. And what we have happening is we've formed our nitrogen oxides or our nitrogen dioxide. It then gets hit with a UV or with UV radiation, and it will split into our NO as well as a free oxygen atom. Now it's this oxygen atom here that goes on to react with an oxygen molecule in the air to form our O3 molecule, which is ozone. Now, from our first dot point, we see that NO2 from reaction between N2 and O2, it will dissociate into our nitrogen oxide and our free oxygen atom, which is our reaction 1, in the presence of UV. Now, that UV comes from sunlight. So that's an important point that we'll be talking about later. The UV light that this reaction needs to occur comes from the sun. Now, our second point is that when we have that oxygen atom that has been liberated from equation 1 with the UV radiation, you react that with our atmospheric oxygen and it forms that O3 molecule. Now, you may have heard of ozone before. It is an important molecule and we definitely need it, but we need it in the stratosphere, so in a much higher layer above the Earth's surface, because when it's up there, it will absorb UV radiation from the sun that would otherwise cause damage to living things on Earth. However, when it's in the troposphere, it is not great. So it's harmful. As I've got here, it harms or irritates living tissue. It damages rubber. So, for example, if you have ozone near a car tire, it will deteriorate it. And it can also harm crops. So you end up with lower yields from crops if there is more ozone in the air. And obviously that is not great. We want to yield as much food as possible from a section of crop. Now, as an aside, our ozone that is meant to be in the stratosphere has been damaged in the past from chemicals such as CFCs, which are chlorofluorocarbons. When the ozone that's meant to be in the stratosphere is depleted, it allows damaging UV light to come in, which has caused an increased prevalence of cancer in countries that are below that hole, such as Australia. Now, in this section, we have just one more bit of information. I've got a graph that I have sketched. You'll find this in the textbooks as well. But what we see here are the proportions of each pollutant. So as the day goes by, you've got our NO concentration, you've got the NO2, as well as another substance, which I have apparently forgotten to label. So I'll have to do that now. Okay, so let's just have a look. So if we've got NO that we have increasing in the morning, we then have an increase in our NO2 because that is a product of our initial reaction with our NO. When we combine those two, you're going to get our O3 forming. Now, O3 is going to be forming from at the time of day where there's the most sunlight, because when there is more sunlight, more UV, you make our NO decrease. We make NO, but that reacts with our oxygen. Here we go. We have most sunlight, which causes this NO2 to decrease. So that's this substance here. Now, yes, we make some more NO, but that immediately will react with other substances as per the reactions that we saw before. The most important bit is that free oxygen there will react with O2 in the atmosphere to make our O3, which will increase. Now, that will start to decrease at this point here when the sun sets, as that reduces the amount of available ultraviolet light for this reaction to be powered. When that decreases, you get an increase in our NO2 that is no longer being broken down by the UV. So this increases as the UV decreases, and this number one reaction can't occur as much.